Alright, so this is composition of transformations notes. It's a combination of, or compositions of transformations are a combination of two or more transformations where the first image, or first transformation, excuse me, let me say this correctly, is done on the second transformation. Two first second. And that's pretty much it for the stuff you gotta fill in. Directions, graph and label each figure and its image under the given transformations. Give the new coordinates. So the most important thing for y'all when y'all reading this is to understand what transformations they asking y'all to do. I hope y'all do. This first one says triangle XYZ has these vertices, and they tell us to reflect on the x-axis followed by xy maps to x plus 9, y plus 2. The first part is easy. They're asking us to do a reflection first. What's the second thing they're asking us to do? Like, what's the name of the transformation? Go ahead, Earl. That's a translation. Thank you, Earl. I need you to know these things. They ask you to do a translation after you do your reflection. So they're asking you to flip and then slide. So first you got to graph the original image on here. And let me talk about this first too. Some kids noticed down here you got a new set of primes here. This is double primes over here. Reason being, because when we graph our stuff, we're going to have our pre-image, then we're going to have our image after our reflection, then we're going to have our image after our translation. You're going to have 3 images on the graph. Y'all not used to this shit. But the more images you put on the graph, the more primes you have to add on. So most of the time it's just going to be up to 3 images on the graph. But sometimes we do ask y'all to do 3 things. So you'll have 4 images on the graph. You have your original, then the 3 images from the 3 transformations we ask y'all to do. So sometimes we do go up to triple prime. We won't go past triple prime though. But for today, y'all gonna see double prime a lot. You may see 1 triple prime in your practice. I can't remember. But single prime notations for your first image. Your second image is double prime. And it's funny because I'm saying this, but then I may end up changing it up when I show you the stuff tomorrow. So when we put it on a graph, you have to have double prime notation just so you can know which images are which. But when they ask you for your answer, like on a test, and you're gonna even see it on our test, we may tell y'all the same thing. We may say reflect and then translate. But the answer boxes we give y'all just all say X prime, Y prime, Z prime. We're not telling you just to do the first thing. We're telling you to do the whole thing and just give us the final image, its coordinates. They just, when they ask you for an answer for final image, they never put like if it's single, double, triple, or single. They always just keep it single prime. But they want you to do all the transformations that they ask you to do in the problem. So I'm gonna tell you straight up right now, no matter what, don't ever ask me the question, do I just do the single prime? No matter what, if you're on a test and we ask you to do however many transformations, do all those, and that final image is your answer that you should type in, no matter what you see in the little prime things out to the side where they asking you. I'm gonna keep repeating that, but I'm gonna try to help it stick in your head. But for now, we're gonna do it the way Mr. Brunson doing it. Triangle XYZ, graph those. Y'all should know how to graph, so we're gonna move fast on that. X, 2, 1, Y, and then -5 up to, let's see. So X, Y, Z. It's very important that you label. I'm going to tell y'all that too. Only I worked the other day. I haven't looked at y'all class. We had a lot of kids do it in first period or second period. I don't care if you sat there and spent your time doing all those images. If your images ain't labeled, I'm marking them wrong. I've been telling y'all this since day one when we started transformations though. So I don't feel bad at this point. So I hope you ain't waste 90 minutes yesterday and don't have none of your stuff labeled. Then after that, that's my pre-image. First thing they asked me to do is reflect over the x-axis. This is an easy reflection. Y'all shouldn't get this one wrong. X-axis. I'm gonna highlight it just to make sure I understand where it's at. X-axis right here. I'm flipping my image over that. To do a flip, all you do is count. I go in order, so they asked me to do X first. X, I'm gonna line up under that. X is 7 up. Go back to my line of reflection. Go 7 down. X prime. Y, line up under that. Y is 1 up. 1 down will be Y prime. Z, lining up under that. 2 up. Go back to the line. 2 down. Z prime. Alright, so if you do that correctly, that should look like a reflection over the x-axis. Then out to the side here, you want to get those coordinates. X prime, it's going to be at -3, -7. Y prime is going to be at -2, -1. Z prime is going to be at -5, -2. So those are my coordinates at the reflection over the x-axis. So I got my second image. Now I need my final one. To get that one, I'm gonna do the translation that Earl was talking about, which is x plus 9, y plus 2. It's telling you what to do. You got coordinates over here already. Make it easy for yourself. Plus 9 and plus 2. Plus 9 plus 2 plus 9 plus 2. Let's do the math real quick, because you don't want to count 9 spaces every time. You can if you want, but you're wasting your time. -3 plus 9 is +6. -7 plus 2, -5. -2 plus 9, +7. -1 plus 2, +1. -5 plus 9, +4. -2 plus 2, 0. Got my new points. Graph that. Should have my final image. So 6, -5 right here. It's gonna be X double prime for me. And then 7, +1. That's gonna be Y double prime. Slide over a little bit. And then the last one, 4, 0. That's Z double prime. Calling that in there. Alright, so that's a reflection over the x-axis, then the translation, x plus 9, y plus 2. Questions on that one? We good? Anybody? Everybody silent? Yeah. You gotta not do more than one thing at once. Honestly, it don't get bad until you have to do a rotation or something else. Y'all be messing up with that. Rectangle. W, X, Y, Z. They say after. You know, I don't want to read it. I want somebody to tell me. I feel like picking on one, but I don't know why I like messing with one. Irvin, right here. This is what they're telling us to do right here. Can you recognize the two things they're asking us to do? They want us to rotate it 270, then they want us to do what? Yeah. Translate -7 plus 3, right? Yeah, okay. So they want us to do a rotation, then a translation. Got to graph the original image first. It's a rectangle. It's going to look exactly like one. It's not even going to be on that crooked. So 1 5 7 5 7 2, and then 1 2. And they call this W X Y Z. Not bad. Just another color. I don't know why. Alright, so my original rectangle here. Once you get it on, they want you to rotate 270. They didn't tell me, so which way am I going? Left, yeah, counterclockwise. 270 is 3 turns. 1 2 3. Should land here. Like I said, looking at it like this, you want to get your coordinates from it. Think about this being straight up right now. Don't think about, oh, it's turned. No, this is how it's gonna look. So you need to get these coordinates. W prime, X prime, Y prime, and then your Z prime. W prime 5 -1. Correct me if I'm wrong. X prime 5 -7. Y prime 2 -7. Z prime is at 2 -1. Once you get the coordinates you need, and you should be writing them sideways like I do. Y'all be trying to cheat me not doing this, and that's where y'all be messing up. Now you can turn your paper back straight. Now you got two options. You can graph just based off that over there. I'll write your stuff in first. You remember on that one when the point's not on the graph, you ain't got no choice. You got to graph first, then write your stuff in over here. Let's just stay consistent. Let's graph this from here first, then write our coordinates. So W prime, we said that was 5 -1. 5 -1 here. W prime. X, we said 5 -7. X prime. Y, we said 2 -7. That's the Y. And then Z, we said 2 -1. This is Z prime. Alright, so that's the rotation. We need to put our points over here. Like I said, on this one, this is around the origin, so your points are going to stay the same. They're not going to change. These are your actuals. So 5 -1, 5 -7, 2 -7, and 2, -1. Last thing you need to do, we translating. Translation says -7 and then a +3. So I would do subtract 7 plus 3, subtract 7 plus 3, subtract 7 plus 3, subtract 7 plus 3. Five minus 7, -2, 1, -1 plus 3, and then -5 minus 7. Some of these numbers are going to be the same, so you can just kind of -7 plus 3, -4. Then you get you get 2 minus 7, excuse me, -5. Then you get -7 plus 3 again. It's going to be another -4. Then you get 2 minus 7 again, -5. As a rectangle, certain coordinates are going to be similar. -1 plus 3, you get +2. They have to be. Then graph that, you should get your rectangle in its final place. So -2 up 2. That's W prime, double prime for me. My bad. Let me show you graphing. That's W double prime. X is at -2, -4, which is X double prime. Y would be at -5, -4. Y double prime. Z would be at -5 up 2. This is Z double prime. Alright, so that should be a final image after the rotation and then the translation. And your coordinates should be over here. And if you get ready, flip to the back. On that one, MNOP. Just want to make sure y'all understand what to do. Mike, you on the back yet, Mike? What two transformations are they asking us to do here, Mike? Oh, number 3, yes, sir. Oh, he said you don't know. Aiden, what two transformations they asked us to do on number 3? Yeah. They asked you to do a rotation, then a reflection. The rotation is of 180 degrees. The reflection is over the line y equals -1. Look, kids last period was confusing that with y equals x. Y equals -1 and y equals x are not the same thing. Y'all should know where y equals -1 is. Do the rotation of 180 first and reflect over the line y equals -1. Do that without me. Whatever that was. Alright. So most of y'all seem to have it. Some of y'all just had some issues y'all had to correct. I think I talked to you about it. I don't think I hit this table over here though. Oh well. I'll get you in a second. Number 4 and 5. Somebody sound like they just lost their life on that. Number 4 and 5, congruency statements. On these, this is a little bit new just because, and you'll see it like this sometimes. Sometimes they'll show you images on the graph that are already the transformation's already done, and they want you to just figure out what happened. thing about it is, and they'll do it like this too, they won't label them the same way like we do. They won't call one ABC and then the other one A prime, B prime, C prime. They may call one ABC and then they may call the other one DEF. And they kind of leave it up to you to figure out what angles go together or corresponding and what sides go together. But if you can see it visually, then you should be able to see what stuff goes together, and you should be able to name correctly. You can't just name with a congruency statement too. You can't just name two figures whatever you want. However you name the first figure, you have to name that second figure the same way. To show you what I mean when I do this over here. But on this one, I think we should find out the congruency transformation first, and that'll help us name it correctly. You got four options. You got translation, rotation, reflection, and then a glide reflection. On this one, translation. Is it a translation? No. Is it a reflection? Is it a rotation? What kind of rotation is that?
Oh, that's a glide reflection.
Yeah, I'm just asking. Yeah.
That's a rotation. That's 180.
Ain't 180. It's not a rotation either. So obviously it's a glide reflection, but let me explain to you why. We did this in the vocab and we haven't touched it since, but we're going to talk about it now. A glide reflection, it's all in the word. Glide sounds like the word what? Slide is a translation, right? So they're telling you glide reflection is a combination of transformations. It's a slide then a reflection. But if you think about it, you can see how the figure slid. This is the original JQV right here. If you look, they slid this image up. Imagine this image coming up here and stopping right here. JQV, slide up, and then they reflected it over the y-axis. Can y'all follow that? Can y'all visually see that? I gotta need to draw that whole thing out for y'all. Can you see it? Me moving this image up here and then flipping it over the y-axis. That's a glide reflection. Alright. That being said, it'll help you figure out what points go with which. So they call it the first one JQV. There's only one way we can name the other one based off them calling that first one JQV. But you got to match up points or angles. Angle J is the same as what angle on my other image? Say it again. E. Angle Q is the same as which one? Which one? W. If you're doing a reflection, think about it. Q is going to be here, flips over, it's going to become W. And then the last one, obviously, V and T go together. That's the only way you can name that one based off the way they named the first one. You have to call it EWT. I'm showing you this because I think we do have a... And I got to see if that question is still on there. We used to have a question on the test. It's real easy. They just named the figure. I think we call one ABC and the other one we call DEF. And we asked y'all, all we asked you was like, angle B goes with what angle? And the images are on the graph, and you just got to figure out which angles go together. Really, it's kind of a matching thing. It's really not hard. I think one of y'all questions is like that, and I think another one of y'all questions might be about a glide reflection. I can't be sure. I have to look at the test again. I'll know tomorrow. Other thing, number 5, similar. Not the same though. Provide a correct congruent statement. Select the appropriate congruence transformation. Isaiah, let's do the transformation first on number 5. What transformation do you see? Say a lot. That is a rotation. Good that you're able to recognize it now. So they rotated triangle LMN. That was the first one. And then LMN became, well, we got to name the other triangle. Based on the way it was rotated and what they named the first triangle, what would you have to call the second one, Isaiah? Say it louder. RST. That's the only way you can name the second one based off the way they named the first one. Got me? Number 6. Don't want to do that with y'all right now. I'm going to say that for tomorrow for everybody. We're going to come back and do number 6 tomorrow. I want y'all to just practice on doing these transformations first. But I want to talk about number 6 tomorrow. We will do this one. Don't lose your notes. Focus on practice.